All right, thanks for the warm welcome. And like you said, my name is Cynthia Lin, and today I'll be talking to you about open source software, the community stack development, and how you can get started on your open source journey by making your first contribution. Now, before I get started, I think a lot of you are interested in how exactly I got up here. So I'm just going to give a brief overview of my experiences in open source so far. So my open source journey began when I started competing in Google Code-In last year. So it was actually quite accidental because how I was introduced to Google Code-In was a Facebook post in a group that I was not supposed to be in. But now I'm here, and after I won a finalist for Google Code-In under Zulip organization, Zulip encouraged me to continue contributing to their project, and eventually I became a core contributor, and I was invited to go to PyCon 2017, where I gave a lightning talk about my experiences so far. And now today, after being encouraged to apply a proposal to PyBay again, I'm here. So I would like to sincerely thank Tim, Rishi, and the other Zulip contributors for making all of this possible, and PyBay for accepting my proposal. Thanks so much.
We love that.
All right, so let's get started with a brief introduction to open source software. So I want to take a poll in here. How many of you use the Linux operating system? Wow, that's a lot of people. Okay, and how many of you use the Atom text editor? Okay, it's a bit less, but still a lot. And how many of you, okay, I expect hands to be up for every single person here. How many of you use the Python programming language? Okay, so what exactly do a open source programming language and text editor and operating system have in common? Well, they're all fitting the definition of open source, which is software that can be freely accessed, used, modified, and distributed by just about anyone, according to the Open Source Initiative, which is a leading organization promoting open source software. Now, what's the difference between open source software and its evil twin, closed source software? Well, both of them use licenses to specify the conditions under which the software may be used. But whereas closed source software limits you to how you can use it, like you'd probably have to reverse engineer the software in order to see the source code, and you probably have to illegally make your own patches if you want to get a fix to the software fast instead of waiting for a bug patch. Open source software is very accessible, and its permissive quality encourages collaboration, adoption, remixing, and transparency. And additionally, the conditions in open source software generally help the software be attributed to its original author and help it retain its aspects of openness. So there are two main types of open source licenses. And one of them is permissive license, which is an example is the MIT license, which a lot of you have probably heard about. So the terms in the MIT license are basically you have the right to distribute, modify, and use the software commercially and privately, as long as you include a copy of the license and copyright in the modified work, because this helps attribute the software to the original author. Now, while this is very permissive, it does claim that we don't have any warranty for just using the MIT licensed software, and we don't have any liability for it. So use at your own discretion. And meanwhile, the GNU General Public License is very similar, but it's a copyleft license, which means that it encourages people to preserve the aspects of open source software by using the same exact type of license in the open source software. So which means that even if you modify a small portion, you need to document what changes you made to the original software, and then you also have to use the same license to use it. So even though you can use it for commercial purposes and private use, you still have to use the same license. Now, on the bottom, I have links to like the open source initiative's collection of open source licenses and choose a license, which compiles a list of open source licenses and the conditions they enforce, so you as a software developer can see which license fits your open source definition the best. Now, given all of the terms of open source, why do people choose to open source your software instead of, say, making it closed source and making the startup with it? Now, open source, its main quality is its accessibility, and this creates a huge opportunities for open source software. And for example, you have a chance to have increased collaboration because it's accessible, so anyone can access it, which means there's a larger pool of an audience that might be interested in your product, which means a larger pool of people that might be more talented and experienced to develop your product. And this also means that it will have better maintenance and quality because people are relying on your open source software, and so they want it to be the best. And because, again, it's not closed source software, you don't have to wait for a bug patch. When they first identify a bug, they will just send one in to the issue tracker and report it, and you can get it fixed as quick as possible. And next, it also has lower costs because even though like you have to spend the same money to run a server, but that's like the same amount of money that you use even though if you're a corporation. And you don't really pay your contributors because everyone is really contributing out of their own goodwill. They love your project and they really want to give back to it. And so therefore, there's not as much money involved in like training your employees or motivating them to work for your project. And finally, it's transparent because source code is all available, so it means anyone can inspect it. So that means anyone can catch security vulnerabilities, which means it's more secure, and anyone can find a bug. And this also means that people are more likely to trust your product because all the source code is available, so you'll know if they're doing something suspicious, like collecting data behind the scenes to sell to some private corporation. And finally, it's more popular because while you're audience, you don't have to pay a fee to access open source software. You can just use it. So its chances are it's going to be more popular, and more people are going to use it, and more likely it's going to have a greater impact on the software industry. Now, given all of this, why do people choose to contribute to open source software? Like right now, it seems like a lot of goodwill involved. Like, open source software is actually a really big journey of self-improvement. You have an opportunity to work with like-minded developers who are interested in developing the software that both of you guys love to use. And you have a chance to be mentored by people with more experience, more professional industry, and they would love to help you gain more knowledge as you contribute to the open source community together. And it's a really big and really nice opportunity to give back to the community after all you've been using the software. Now, let's get started on dissecting the anatomy of an open source project, like what parts are there and how exactly does it function. So this is a very important part, the project code base, because this is the one thing that all of you are interested in maintaining and promoting. Now, the open project code base is usually where all of the source code of the project is located. And it's usually stored in a repository of a distributed version control system. And basically, version control is a software development practice where all changes to a particular software are collected and recorded so that you can easily revert changes if they suddenly break your code, and you can review the history of it. So it's kind of like the Google Docs revision history, but for code. And additionally, version control helps collaboration easier because you have a centralized repository, right? And a main repository where everyone forks a smaller version of your repository over. And you guys work on parallel lines of development called branches, where you can work on multiple features at once. And once you deem those features are appropriate, you submit the pull request to the main repository, and everyone reviews it and merges the change once they feel like they are necessary. And next, we have the first part of the project code base, the issue tracker. So they're also known as bug trackers, mostly because it's where people usually submit bug reports. Now, most open source projects actually have something called issue templates because they care about the quality of the issues that you guys submit. So they will say, when you submit an issue, we'd like you to see, explain the expected behavior and the actual behavior and how you think this could be solved and other stuff like that. Now, issues are usually open because you want to report an error that you can't solve yourself, or you want to actually request a new feature saying, I have a use case for your software, and I think it would be enhanced if you implemented this feature X, Y, and Z. And it's very a nice opportunity to create a discussion forum-like environment with discussion of high-level topics and ideas. And like I mentioned earlier, there are pull requests involved in the code base. Basically, once you make changes to your fork of the main repository, whereas issues are more like starting a conversation or discussion, pull requests are like starting the work on a solution to a problem. So pull requests are a way for you to submit fixes to the code base, and pull requests allow project maintainers and code reviewers to see the changes that you made in the pull request, and they can suggest improvements to it, saying, I think you could solve this problem by doing this in X, Y, and Z instead of A, B, C. And the pull requests also serve as a way for testing to get passed, because pull requests, they're like a preview of what happens if you merge it into code base. And finally, you have project milestones, which are really important towards project management, because you want to plan for specific features and releases, and you want to know how far along the project is going. You use specific issues and pull requests that mark points in the timeline which indicate how far the project has been progressing. And finally, you have documentation of a code base, which is basically like a roadmap guide to the code base. You have the README document, which introduces new users to the project, saying, this is what our project is, this is how you can use it, and this is what our vision is. And it also usually has a link to the contributing guide, which is basically a guide to encourage you to contribute to the project by describing what practices we use to make your contribution go along and what types of contributions we are looking for. And finally, you have a code of conduct, which is a very nice set of rules that help define the expected behavior for all community members to create a more welcoming and inviting environment. And you also have other stuff, like especially in large open source projects, you have governance policies, which are basically like ethics and morality rules to say how you use your project. Again, like I previously stated that you can't really limit who can use your project, but what if you make some software and someone's using it for a phishing attack and you don't want it to be used for malicious purposes? Well, governance policies are here to protect your software from being misused. And you also have developer-oriented tutorials and guides to help contributors learn how exactly things go on in your code base. And like any industry, open source projects use several software development practices to ensure code base quality, including continuous integration, which is the practice of running automated tests to ensure that code can be continuously integrated without introducing bugs, and coverage tests, which is a measurement of how much the code base is tested when test suites run, and you write tests specifically to cover the entire code base so you know nothing will ever break. And you have quality assurance, which is basically ensuring that the development and maintenance processes produce the best possible product. And you set minimum standards, and you see if your current practices meet those standards, and if not, decide how you can improve to meet those standards. And like I said, you have various types of testing to ensure that all of your code base is being tested, including unit testing, where small portions of your code base are tested in isolation, integration testing, which are ensuring those small units of code work together, and functional testing, which is comparing the results of a given input against a specification. For example, like a function that squares two numbers, and it says if 3 squared is supposed to be 9, it comes out as 6, then you know something's wrong. And acceptance testing, which is ensuring that the tests on the entire application match both developer and customer specifications so that no bugs are produced. And finally, you have the heart of the open source community. And basically, they're just users, developers, contributors, project maintainers, anyone that's involved in making open source software better than it is. So they usually use synchronous chat clients like Slack, RRC, or Gitter to communicate, but these days there are a lot of more other options for communication, including other open source chat clients like Mattermost, Rocket, and Zulip. And next, they might actually use mailing lists or discussion forums to collaborate. Now, this is how I like to visualize the structure of an open source community. So the outermost circle represents the largest class of community members, the users of the product. Now, you might say, well, they don't really do much. They just use our product. They don't really contribute back. But they kind of do, because they're the ones catching bug reports and using it in miscellaneous ways that you guys, as a developer, might have never used. And they're the guys requesting future implementations because they have a specific use case for the product. And they also return significant feedback to changes like product releases. They might also make minor contributions, like your documentation has a typo. I'm going to submit a pull request to fix that typo. And next, you have contributors in the inner circle over there. And they are the people that are actively contributing code to the code base by responding to issues in a project issue tracker and creating pull requests to resolve them. Now, contributors have varying levels of experience, but often collaborate to expand and enhance the product. Now, next, you have core developers, which are basically contributors, but they're more experienced and have been with the project a long, long time. So they often end up mentoring new contributors and welcoming them into the project and teaching them how exactly a project works. And they often specialize in specific parts of the code base. So you might have John specializing in tooling and Bob specializing in front-end development. But they all want to make sure that you are welcome in the community, and they want to do everything possible to give you a welcoming experience in the community. And finally, at the center, you have project maintainers. These are the people who are responsible for pushing commits to the master branch, and they're the leaders and administrators of the open source community, and they dedicate all of their time to overseeing, managing, and expanding the project code base. And whereas contributors and code developers are more oriented towards contributing code, a project maintainer's main responsibility is to manage, see which pull requests are going in and review them. And there's less code writing involved, but they do also, like the core developers, mentor others. So you might ask me why I chose to represent it in a series of concentric circles instead of, say, a Venn diagram or a pyramid. That's because this reflects that the if and only if logical concept. Like, you know how every square is a quadrilateral and a rectangle and a rhombus? But everyone seems to forget that project maintainers, before they were project maintainers, they were once users, they were once contributors, and they were once core developers. So they're kind of like the squares in the open source community. They're a project maintainer at heart, but they are also users, contributors, and core developers, and they share some of those basic responsibilities too. Same as core developers. I mean, core developers are like rhombuses. They might not be squares, not all the time, but they might be quadrilaterals, and they might be parallelograms. And so this applies to generally all of the classes in open source community. And also, you'll notice that there's dotted lines around each circle. And this serves to illustrate that there are no really strict classes in open source community. And you can easily transition from being a user to a core developer with enough time and dedication. There's no saying, oh, you have to be this experienced or you have to contribute this It's more like how much passion you have for the project and whether the other community members see that you have this passion for the project. And there are several other roles in the open source community other than, say, contributing code. Like you have event planners that plan and organize events, meetups, and conferences to meet at, and code sprints to bring the community closer together. And managers to answer questions on discussion forums or mailing lists and respond to user feedback, like bug reports or feature requests about the product. And you also have designers to improve the user interface and interaction of the product by enhancing the project's usability, navigation, menus, graphics, branding, visual appeal. And you also have writers to write and improve user-facing documentation, tutorials, create examples, demonstrate how the projects can be used, and maintaining maybe a newsletter for the project. And you also have translators to translate and localize the product to other languages. And finally, you might have some promoters advertising the project on social media, word of mouth, or blog posts to increase its popularity. Now, even like developers without like strong programming skills, like they don't feel comfortable like fixing bugs or like implementing features, they can also write developer documentation tutorials or guides if you're more of a writing type of person, or they can actually write developer tools and automate tests for the code base, which both helps developer experience easier, or they can review the pull requests of their fellow contributors to verify that the functionality works through manual testing or suggesting improvements to the code. And now let's talk about how exactly you can make your first contribution to an open source project count. So first things first, you have to identify an open source community to contribute to. Now, like, what exactly makes a community worth contributing to? Well, number one, you should be passionate about what you're doing. Like, do you feel very enlightened by their project philosophy, or like, do you use the project often? Those are good candidates for your first project to contribute to. And there's also several resources available to find projects that are worth contributing to. Like GitHub Explorer has an entire collection of projects that you can contribute to. Like the one category is the great for new contributors, which is basically GitHub has actually verified that these projects are very, very welcoming to new contributors and that they're worth contributing to. And you also have Code Triage for seeing what issues are available to be worked on, and same for Up for Grabs, which are introducing you to some issues and some popular repositories that might need your attention. Now, here is like a huge checklist of projects that you might be interested in contributing to. Looks like it got messed up a bit, but projects you might be interested in contributing to have, well, your issues, your projects you contribute to regularly, and you have a focus you're interested in. But how many issues are open in the project right now? Is it 0? Is it 100? You want a large collection of projects to issues to actually think about contributing to, because it shows that the project is active. And are the maintainers responsive to any issues that are recently opened? Like, do they actually actively respond, or do they take 2 weeks to reply? Like, if they take 2 weeks to reply, chances are the project is not very active, and you might want to consider a different project to contribute to. And are there issues, any issues recently resolved? Because it shows, again, that the project is active and they're actually caring about improving their product. And same with pull requests, actually. Pull requests, they show how many bugs or people think that need to improve, but do maintainers actually take the time to give proper code reviews? Like, and are they actually offering feedback so that it can get merged easier? So those are some things to keep in mind. And finally, the community, which is a very important part. Are the communities, is the community helpful? Is it responsive to your questions? Is it friendly? Does it encourage positive collaboration and discussion? Again, pull request reviews, and again, the code of conduct signifies that it actually cares about its contributors and wants a welcoming environment. Now, here are some of the steps involved when you make your first contribution. Now, the issue tracker is probably where you're going to get started. Now, you will identify a problem that you want to solve, or you can propose an improvement to a problem. And this starts by you either find an issue that describes a problem you're expecting, or if you can't find any, you open an issue for it. And after that, you go talk to the developer community and ask, so I created this issue, do you think it's valid? And they will actually take time to respond to the issue itself. If they think it's valid, it's like, oh, continue with it. Yeah, this is a really big issue we need to get resolved. And so this is kind of like a prompt for you. It's like, go ahead, solve the problem. And to do this, you may fork a copy of the repository, and you submit a quick fix, and you create a separate branch for your changes, and you document proposed changes in pull request, and a maintainer will actually take time to review your code and make sure your tests pass, and then they will ask for additional changes to your present pull request, and once they feel that everything is okay, they will merge and you will have your first contribution. And here are some tips and tricks I like to keep in mind when you're contributing. When you're asking for help, make sure to give context, like describe expected behavior and describe the actual behavior so people can actually find out what's going wrong and how they can help you. And next, you should do your research. There is usually a plethora of developer documentation available on the great open source projects. So contributors like you who need help, maintainers don't need to spend every 5 minutes responding to a question. They have FAQ, developer tutorials, guides, and everything that you should know before you ask a question. And again, it's okay to ask questions, but make sure to do your research because they know that sometimes maybe the documentation is a bit obscure, maybe you need a quick fix, and they will easily answer your question. No one's going to judge you. And next, patience is a virtue. Everyone is usually working on their own time for their project, so they might not be available 24/7. This isn't really customer support service. So they actually would appreciate if you took the time to sit down and wait for them to get back to you. You're not ignoring you if 24 hours. I mean, you should have checked if the project was active enough, but they will eventually get back to you, hopefully. And you should offer to do the dirty work. And it's really funny because usually the dirty work is the more new contributor-friendly stuff, like writing documentation or writing tests, or something people consider boring, but it's very easily implemented. And by offering to do the dirty work, you will prove yourself as a very valuable member of the community, and people will recognize you for that. And next, you should treat everyone with respect. If a maintainer rejects your contribution, saying, oh, I think you have some problems, you shouldn't improve your pull request, or I don't think your pull request is really needed in our code base because it doesn't really align ourselves with the project vision. You shouldn't feel offended at all. I mean, you should respect your opinions, and they do respect yours. I mean, they are taking the time to consider your opinion. And next, you should be humble, but you should also be bold. No one's gonna realize that you're in deep trouble, but no one also wants you to brag about your accomplishments every other minute. So it's a very delicate balance of being bold enough to ask questions, but not boasting yourself or throwing yourself all over the place. And finally, communicate effectively, which is just about a summary of everything in here. So in conclusion, open source software is software made for everyone by everyone. And it helps the community grow if you contribute to open source software, but you as a person can actually contribute. As you can see, it's very easy to get started, and open source communities are just waiting out there for your first contribution. All right, thanks for listening. And the slides are up there, so I'm open for questions right now.
Great talk, thank you. So how did you get started in programming? I'm curious.
Programming, in middle school, I had a science teacher who was very invested in programming, and so he introduced me to Scratch, which is like a block-based programming language by MIT. And so I got started with that, and then after that I learned Python, JavaScript, other languages, and yeah.
Hey, thanks. Two questions. First, what would you say to other young people who want to become involved in open source? There's probably a little bit of a barrier as, I have a son in high school, and so he's, not sure he wants to kind of take the plunge. What would you say to encourage that kind of behavior? And then secondly, could you talk about some of your open source areas that you work in now?
Okay, so to your son and like other kids who are probably interested but aren't too interested in taking the first step, I think there's really nothing to be afraid of. Like the only bad thing about being younger than most of the community is that you can't participate in drinking parties. So, I mean, there's nothing much. Everyone is pretty happy that you're getting started at such a young age, and they really respect you for that. And generally everyone's pretty kind, so there's nothing to be afraid of. Everyone's pretty open. And like I said, Google Coding is a great way to get started because it actually puts incentives like points to collect so you can get started in the open source community. And as for, what was your second question?
Open source now. Can you talk a little bit about what you're doing?
Oh yeah, so I'm a core developer for Zulip, an open source group chat application, and I also do a side project for Zulip called ZulipBot, which is basically a GitHub workflow optimizing bot. It yells at people when they don't work on their issues. So.
Another round of applause.